Very good morning to all of you. Hmm? So can you hear me? Hmm? मेरी आवाज आ रही है क्या आप लोगों को? Can you hear me? Please reply me. Most of the students are saying to sir today we have exam, backlog examination is there, correct? So don't worry, I will upload this lecture on YouTube and I will send the link on गूगल क्लासरूम एज यूजुअल जो मैं आप लोगों के लिए करता आ रहा हूँ. सो जो लोग भी आज का लेक्चर लाइव अटेंड नहीं करोगे वो मेरा लेक्चर बाद में देख सकते हैं यूट्यूब पे, ठीक है? सो डोंट वरी अबाउट दैट. गिव योर एग्जाम कॉन्फिडेंटली. Okay, so all the best for your examination. For those who are having backlog, those who do not have backlog, please attend my lecture. Okay, so in the last lecture what we have discussed, in the last lecture we have discussed the factors which affect the rate of reactions. Different factors are there. 5 factors we have discussed, that is temperature we have discussed, then uh, uh, concentration of reactant we have discussed, concentration of product we have discussed, presence of catalyst also we have discussed, and last one is particle size of the reactant. This last factor, that is fifth number, particle size of reactant, is important in case where one of the reactant is present in solid state. In that case the size of the particle is important, because the smaller the size of the particles of that reactant, greater is the surface area and higher will be the rate of reaction. That we have discussed in the last lecture. In the last lecture also we have discussed we have derived the integrated rate law equation for zero order reaction. What is the zero order reaction, you know now very well, and for that zero order reaction we have derived one rate law equation, that is integrated rate law equation for zero order. And after that we have seen characteristics of the zero order reactions. In that we have seen first units of the zero order reactions, then we have seen half life period, that is T half, and last is nature of graph for zero order reactions. In today also we will derive the integrated rate law equation for first order reactions. Same we will discuss as like yesterday's lecture, and again we will discuss the characteristics for first order reactions. Three characteristics are there for all reactions. Say for example zero order, first order, second order reactions, third order reactions. Three characteristics are there. First is units. You should know the unit of that particular order of reactions. Then because unit is different for different order of reactions, unit changes with the order of reactions. For example, zero order reactions, one unit is there, and for first order reactions another unit is there. Unit is not same for all the reactions, it depends upon the order of reactions. Okay, so unit we will discuss. Then we will discuss the T half. It is also different for different orders. T half भी क्या होता है, डिफरेंट होता है. जीरो ऑर्डर के लिए अलग होगा, फर्स्ट ऑर्डर के लिए भी अलग होगा, सेकंड ऑर्डर के लिए भी दूसरा ही होगा. ठीक है. देन वी विल डिस्कस द नेचर ऑफ ग्राफ. अगेन दिस नेचर ऑफ ग्राफ इज आल्सो डिपेंड अपॉन द ऑर्डर ऑफ रिएक्शन. मतलब ये कैरेक्टरिस्टिक्स जो पॉइंट्स है वो हर ऑर्डर के डिफरेंट है. दैट वी विल डिस्कस. ठीक है. सो टुडे वी विल स्टार्ट विद द फर्स्ट वी विल स्टार्ट विद द integrated rate law for first order reactions. ठीक है. So we'll start it. This is your lecture number 3 of chemical kinetics. We have discussed in first lecture introduction, different terms in chemical kinetics. Second order we have in the second lecture we have discussed the factors affecting and the integrated rate law for zero order reaction, and this is lecture number 3. This is your lecture number 3. In today's lecture we will discuss the integrated rate law for first order reaction. Okay, so shall I start the lecture? Please reply. Shall I start the lecture? कौन कौन आया lecture को अभी? Are you ready for this derivation? If yes, then take the pen and notebook, because in this lecture most of the mathematical terms are there. So you have to write it down. Then and then only you will understand, or you will come to know that how to derive the integrated rate law equation. So those students which are having mathematical subject for SY and FY level, they will understand it better. For those do not have a mathematical background, for those students, it is little bit difficult to understand. Okay, so if you have to practice it, you have to write down the equations, all the equations for first order, second order reactions. आप लोग अगर practice करोगे तो वो easy होगा. Otherwise, it is very difficult. So please take pen and notebook. ठीक है, so shall I start the lecture? Okay, so in today's lecture we will discuss the integrated rate law expression for first order reactions. So this first order reactions contains, you know that the first order reactions contains only one concentration term which has an exponent equal to 1, because अगर उसका exponent और power कितना है 1 है, then and then only that reaction is first order reactions. ठीक है, अगर उसका पावर कितना है, concentration का power 2 है, then it is second order reactions. कोई भी power नहीं है, that means 0, then it is zero order reactions. An example of the first order reactions is thermal decomposition of N2O5. Thermal decomposition of N2O5 into N2O4. And second example is thermal decomposition of gaseous acetone. These two examples are there for the first order reactions. Okay, so for the sake of simplicity, we will take a very general reactions that you know now very well. The A goes to product. We will take these reactions only. Okay, very simple reactions, generalized equation. Here A is reactant and this product is formed. So to these reactions, according to the first law or first order reactions, we will write down the rate. Now you know how to write down the rate. Here rate is equal to negative D concentration of Ca, that is concentration of A. What is the meaning of Ca here? What is the meaning of Ca? Ca is concentration of reactant A. That is the meaning. C is for concentration and A is your reactant A divided by dt. So negative dCA by dt. Why negative sign is there? Because the concentration of reactant is decreases. That's why negative sign is there. So in this way you have to write down the rate for this equation. Okay? Sorry, these reactions. Again, we will write in terms of constant here. R is equal to, because rate is indicated by symbol small r, is equal to K1 into concentration of A, that is reactant, and here K1 is rate constant for first order reaction. Why 1 is there? Because the order is, it is a rate constant for first order reaction. That's why 1 is written. It is a rate constant for first order reaction. That's why K1 is there. And if we equate this both equation, this equation and then this equation, you can write here minus dCA by dt is equal to K1Ca. If we equate this equation, because here only this and this is same, because we have written this is in terms of rate constant K1 and R is denoted by small r. So if we equate this equation, you can write this one. Okay. Okay. Then if we rearrange it, for example, we will take dt into this side and Ca into left side. So what will happen? Minus dCA by Ca is equal to K1 dt. We have just rearranged this equation. We have rearranged this equation. T को हम लोग कहाँ पे लेके गए? इधर. And this Ca को हम लेके आए यहाँ पे. So after rearranging, we will get minus dCA by Ca is equal to K1 dt. Call this equation as equation number 1. ये आप लोगों का हो जाएगा equation number 1. So this is your equation number 1. Minus dCA by Ca is equal to K1 dt. Okay. Then we will integrate this equation. We will integrate the equation number 1. This equation को हम लोग क्या करने वाले? We will integrate within the limits of what? Within the limits of time and within the limits of concentration of reactant. ठीक है. So how will you integrate? Integrate the equation number 1 within the limits of t is equal to 0 to t is equal to 2. This is the limit. T is equal to 0 to t is equal to 2 for time t. It is for, if this limit is for time. And then Ca is equal to C0 to Ca is equal to Ca for a Ca, and where C0 is the initial concentration of reactant A. C0 is what? It is the initial concentration of reactant A. Please remember this. C0 is initial concentration and Ca is concentration after time t. Concentration after time t. ठीक है. So after integrating above equation, that is equation number 1, what we will get? We will get this equation. So we will integrate minus integration 0 to CA dCA by CA is equal to integration 0 to 2, this is our limit, 0 to t k1 dt. Now here k1 is constant, that is called as a rate constant for first order reactions. We will take because it is a constant, we will take that constant as a outside of the integration. So it will gives you k1 integration 0 to 2 dt. So in this way we will get the equation after integrating. Then what we will get? If you solve this, minus ln Ca C0 to Ca is equal to k1 t 0 to t. This equation will get. This is the limit. This is the limit, and for concentration, and 0 to 2 is the limit for time. Okay. Okay. Then here this ln term is there. So this ln term is stands for log to the base e. This ln stands for what? It is stands for log to the base e. Then next, after subtracting, so we will subtract upper limit Ca minus C0, here t minus T0. So after subtracting upper limit, lower limit from upper limit, we will get this equation, minus ln Ca minus ln C0, which is equal to k1 t, because t minus 0 will give you t, so k1 t. So after subtracting, you will get this equation. After subtracting the limits, you will get this equation. Okay. Then we will get this ln C0 by Ca is equal to k1 t. We will get this. Okay. Then we will change the base 10. Here it is a ln, so we will change the above equation to the base 10. We will get this equation, log e 10 into log 10 C0 by Ca is equal to k1 t. Okay. So and for this log e, we will write 2.303 into log 10 C0 by Ca is equal to k1 t. So we will get this equation. Okay. Now we will rearrange this equation. ये हम लोगों को मिला है ना this equation. So we will rearrange this equation in terms of k1. We will arrange this equation in terms of k1. So we will get k1 is equal to 2.303 by t into log C0 by Ca. Call this equation as a 2 equation. We will call this equation as a equation number 2, and this is your integrated. This is your integrated rate law equation. This is your integrated rate law equation for first order reactions. Okay, and here the log stand for log to the base 10. Please remember this. This log stands for log to the base 10. But this is your integrated rate law equation. But this is not more useful form. It is not a more useful form. It is a, no doubt it is integrated equation of first order, but it is not a useful form. Here concentration C0 is written, Ca is written. So what we will do? We will derive the more useful form for the first order reaction. So instead of C0 and Ca, we will put the particular values. Okay. So we will start with the initial concentration. For example, let us consider if A is the initial concentration of reactant A. Here we have taken C0 as the initial concentration. Instead of C0, we will take A is the initial concentration of reactant A, and X is the number of moles of the product formed at a time t. Here we have taken it as a Ca. So here instead of Ca, we will take X. And what is the X? X is the number of moles of the product formed at a time t. Then the concentration of unreacted reactant of A at a time t will be A minus X. Now you know that very well. हम लोगों ने last lecture में भी देखा था. Then the concentration of unreacted reactants A at a time t will be A minus X mole. So we will substitute the above value in the equation 1 जो हम लोगों ने derive किया था ना, this वाला equation. This is our equation 1. So in this equation, instead of these two value Ca and C0, we will put the X and A and X minus X. So this is our equation 1. So in this equation we will put this value. So here we will get minus Ca, instead of Ca we will put A minus X by dt. This is your reactant. This is in case of your reactant. Then we will write one more equation in case of product. So here dx is nothing but the what is X? x is the number of moles of the product form at a time t. So here negative sign is there because these are reactants, and you know that the concentration of reactant is decreased, that's why negative sign is there. And here no negative signs because of this is in terms of product, and concentration of product is increases, so no negative sign is there. So dx by dt is equal to k1 a minus x. So we will write this equation in terms of product. We will take dx by dt is equal to k0 a minus 1. We will take this equation and we will solve, or we will derive the integrated more useful form for integrated rate law equation for first order reaction by using this equation only. We will consider for a product in terms of concentration of product we will consider. Okay, so okay, let us start. We will rearrange this equation. We will rearrange this equation first of all, and after rearranging we will get, here we will rearrange it. So क्या किया हम लोगों ने, dx by a माइनस एक्स इज इक्वल टू के वन डी टी, वट एवर ये जो टर्म था ना हम लोगों का, ये इसको हमने यहाँ पे लेके आए और डी टी यहाँ पे राइट हैंड साइड. ठीक है, सो आफ्टर रीअरेंजिंग वी विल गेट डी एक्स बाय ए माइनस एक्स इज इक्वल टू के वन डी टी. दिस इज आवर इक्वेशन नंबर 3. दिस इज आवर इक्वेशन नंबर 3. now at a time t0, please remember this, at a time t0 x is equal to 0, and what is this x? X is the moles of product. X is mole of product. And at a time t0 there is no product form, that means no reaction has occurred because हम लोगों ने reaction अभी start ही नहीं किया है. That is your t0. That is your t0. And at a time t is equal to t, at a time t is equal to t, x is equal to x. And what is this x? X is nothing but the moles of product form. So we integrate this above equation within these limits, that is equation number 3. And after integrating we will get this, we will get. So we will integrate within the limits of x is equal to 0 to x dx by a minus x, and for time 0 to t k1 dt is equal to, so now here again it is a constant, you know that it is a constant, so we will take that constant outside of the integration sign. So k1 is equal to integration of 0 to t dt. So after integrating this equation number 3 we will get this one. आप लोगों को क्या मिल जाएगा, ये इक्वेशन मिल जाएगा. सो एंड आफ्टर सॉल्विंग दिस इक्वेशन वी विल गेट माइनस ln a minus x 0 to x is equal to k1 t 0 to t. This is your limit for number of moles of product form, that means for concentration, and this is limit for your time. ठीक है. So after subtracting from upper limit lower limit from upper limit we will get minus ln a minus x minus ln a is equal to k1 t. ठीक है, so you will get t here only because t minus 0 will give you t. So after subtracting lower limit from upper limit you will get this equation. Then we will write this ln a by a minus s is equal to kt. We will get this equation, and changing the base 10, ये जो equation है ना ये ln, we will change the base for this ln is equal to base 10. We will get this equation, that is 2.303 into log 10 a by a minus x a on kt. After changing the base 10 we will get this equation. Then we will rearrange this equation. We will rearrange this equation in terms of rate constant, that is k1. So k1 is equal to, ये t क्या है यहाँ पे, डिवाइड इधर जाके क्या हो जाएगा, मल्टीप्लाई हो जाएगा. So k1 is equal to 2.303 divided by t log a by a minus x. This is your useful form of integrated equation. This is your integrated rate law for first order reaction, not zero order reaction, here first order reaction. So this is your integrated rate law equation for first order reaction, which is very important. And for characteristics, to find out the units, to find out the nature of graph, to find out the t half, you have to take this equation only, or this equation you have to take. ठीक है, or you have to take this equation. ये दो these and this equation is the same. We have just rearranged this equation. ठीक है, so to form or to find out the characteristics we have to take this equation. ठीक है, understood this? Have you understood this or not? The integrated rate law equation for first order reaction, that is k1 is equal to 2.303 divided by t log a by a minus x. Please remember this equation. K1 is equal to 2.303 divided by T log A by A minus X. This is your integrated rate law equation for first order. This is your integrated rate law equation for first order reaction. Okay, have you understood this? Okay, so now we will see the characteristics for zero order reaction, and first characteristic we will see that is unit. First characteristics we will see that is unit. So starts with this equation. This is your integrated rate law equation for first order reaction. I have told you we have to start with this equation only. K1 is equal to 2.303 divided by T log A by A minus X. Okay, so what we will do here? Here A and A minus X, these both are concentration term, because A is the initial concentration and A minus X is the concentration of reactant remains unreacted. So both are concentration term. So this concentration term will get cancelled. This concentration term will get cancelled. And here 2.303 is again constant. ठीक है, 2.303 क्या है? Constant है. So क्या बच गया? Only T inverse बच गया. So therefore the unit for first order reaction is reciprocal of time t, that is time inverse. What is the unit for first order reaction? टाइम टी. एंड जीरो ऑर्डर रिएक्शन क्या था? मोल्स पर लीटर पर टाइम था. यहाँ पे क्या है? ओनली टाइम टी. एंड इफ SI यूनिट विल राइट पर सेकंड. सो दिस इज द यूनिट फॉर फर्स्ट ऑर्डर रिएक्शन, पर सेकंड. This is the unit for first order reaction, that is per second. Then the second we will see the half life period. Second characteristic is half life period, and you know that what is half life period? It is a time required to complete half of its initial concentration. It is called as a half life period for that particular reactions. For example, during the T half, both the reactant and product, they are present in 50-50 percentage. At that time we will call that time as a half life period. So we will find out the half life period. Here you know that very well now. Here when T is equal to T half, initial concentration is also A by half and product from X is also A by half. You know that now. So both are present in 50-50%, and that time we call that time as a T half. So let us take this equation, which is integrated rate law equation for first order reaction. K1 is equal to 2.303 divided by T log A by A minus X. Okay, so instead of this A and A minus X, we will put this value. Okay, so after putting and rearranging, we will get K1 is equal to T half. So T जो था हम लोगों ने ट्रांसफर किया है this side. So K1 instead of T, here we will put T half. So K1 T half is equal to 2.303. Instead of A, we will put A. ठीक है, no problem there. A minus X, we will put A by X. A minus X, we will put A by X. So what will happen? This A and A will get constant. A and A will get constant. We will remain only this. K1 T half is equal to 2.303 log 2. And if we will take log 2 and multiply that value with 2.302, we will get this 0.693. So K1 is equal to T half 0.693. And if we take this K1 यहाँ पे multiply था to this side, so what will happen? It will get divided by. So T half is equal to we will get this equation. T half is equal to 0.693 divided by K1. This is your half life period. This is half life period. See here, this equation is there. T half is equal to 0.693 divided by K1. This is your half life period. ठीक है? Understood this? Yes or no? Have you understood this? Yes or no? Unit for first order reaction is per second, that is time inverse. Half life period is T half is equal to 0.693 divided by K1. Okay. Then the last characteristics, two characteristics we have seen, the units and half life period. Half life period, you know that it is a time which is required to complete half of its initial concentration. It is called as a half life period for that reaction. And when T is equal to T half, A is equal to A by 2 and X is equal to A by 2. Start with this equation. K1 is equal to 2.303 divided by T into log A by A minus X. And if you transfer this T into the left hand side and we will put this value A minus X is equal to A by half, you will get K1 T t half is equals to 2.303 log a by a by a divided by a by 2. So this a and this a will get constant. We will end up with 2.303 into log 2. Take the log 2 and multiply that value by 2.303. We will get 0.693. And if you rearrange in as per your t half, you will get 0.693 divided by k1. This is your half life period. Okay. Then we will see the last characteristic is the nature of graph. Last characteristic क्या है? Nature of graph. So starts with this equation. I have rearranged this equation. K1 t कहाँ पे था? T was here. So I have transferred this t into this side. So K1t is equal to 2.303 log a by a minus x. ठीक है? So now we will rearrange this equation. We will rearrange this equation. We will get log. So what we have 2.303 था ना, इसको हम लोगों ने this side transfer किया. So we will get log a by a minus x is equal to k1 2.303 into t. After rearranging we will get this equation. ठीक है? Then we will solve this log a minus log a by log a minus log a minus x, which is equal to k1 2.303 into t. Then we will transfer this log a to this side. We will transfer this log a to this side. So what will happen? क्या रह जाएगा यहाँ पे? माइनस लॉग a माइनस x इज इक्वल टू k1 2.303 t. ये यहाँ पे इधर क्या था? प्लस था. इधर आके क्या हो जाएगा? नेगेटिव हो जाएगा. सो नेगेटिव लॉग a. ठीक है? Then we will multiply this equation. We will multiply this equation by minus 1. We will multiply this equation by minus 1. So what will happen? Here minus minus will get plus a minus x. यहाँ पे क्या था? Plus minus 1 will get minus k1 upon 2.303 t. यहाँ पे क्या था? Minus. So minus into minus 1 will get plus log a. So after multiplying this equation by minus 1, we will get this equation. We will get this equation. ठीक है? So this equation, if you see this equation, it is in the form of y is equal to mx plus t. So this whole term is called as a y. This whole term is called as a y. M is nothing but minus k1 divided by 2.303. T is nothing but the x and plus c. So c term is log a. So this represents a straight line with slope m. This equation represents y is equal to mx plus c. That means it is a straight line with slope m and intercept c on x-axis. So log a is the intercept c on x-axis. ठीक है? So if we plot the graph of log a minus x versus t, क्या नेचर आ जाएगा? I will show you. If we plot the graph of log a minus x versus t, your graph will be like this. ठीक है? For example, we will plot this graph. On the y-axis, we will take y-axis पे क्या होगा आपका? Log of a minus x, and here on x-axis time. So we will plot a graph of log a minus x versus time, and it is a straight line. It is a straight line passing through origin. ठीक है? Now here हम लोगों ने देखा here slope is negative. ठीक है? Slope in m is what? M is your slope. So slope is negative. Negative means nature of the line is like this. So here you will get the slope. If you plot this slope, you will get slope here, and this slope is equal to negative k1 2.303. This is your slope. And if we plot in terms of k1 is equal to what we will get? Slope into 2.303. So by knowing the slope of graph, you can find out the rate constant for this first order reaction by using this equation. If you know the slope, after getting the slope, you can find out the rate constant for first order reaction by using this equation, which is very, very important. And now what we left? The slope intercept on y-axis, that is log a. Intercept is log. This is your intercept. So this is the nature of your graph. This is the nature of your graph. Okay. So with this, I think we'll stop here because your exam is there. I don't want to take much time of yours. So we'll stop here only. In tomorrow's lecture, uh, we'll discuss the rate constant for or we will derive in tomorrow we will derive the rate integrated rate equation for second order reactions. Today we will stop here. Whatever the examples of zero order reactions, first order reactions and second order reactions, that example we will see after the completion of this chapter. After the end of this chapter we will see the examples. Okay. So if you have any problem, any doubt, you can ask me. If no problem, then it's okay. You can go and you study hard. I will active the link for your attendance also. Don't worry about that. Give the attendance. Okay. So shall I stop here now? So now I am activating the link so that you can give write your attendance. So because your attendance is very important, because for your internal assessment also there are 5 marks. Okay, so your attendance is also very important. आप लोगों को lectures attend करने चाहिए. Then and then only you will get the marks. So I have attended. So I have activated the link. Give your attendance. Any problem? No problem. Everyone is saying no problem, sir. Alan is saying no problem, sir. Akriti is saying no problem, sir. Okay. So no problem. I will stop here. Sagar is saying mid semester exam कभी आए sir? That I don't know. सागर उसका टाइम टेबल अभी तक नहीं आया है. टाइम टेबल आने के बाद आई विल इन्फॉर्म यू. डोंट वरी अबाउट दैट. बट वी हैव lot of syllabus left. This chapter we have 3 to 4 lectures we have left for this chapter, and one more chapter is there, that is adsorption. ठीक है, surface phenomenon, that also we have to discuss. ठीक है, so we'll go little bit fast we will go. ठीक है, ठीक है, so don't worry. I will not take your time. Attend your exam. All the best. Bye bye. Take care.